Once again, good evening, everyone, and welcome to our second session of our Rice Explorations in Computing and Engineering for Teachers series that we're doing in conjunction with CSTA Greater Houston. And it's an exploration into CreatiCode, and we have with us the CEO and the creator of CreatiCode, which is Dr. Ben Yu, and he's going to be walking through some of these different aspects of the program and let you have an experience where you're able to work through everything that has and see what you can do with your students with this platform. As a matter of fact, this week with it being CSA week, I think it's an apropos time to have this discussion and to give your students something interesting and new, a new way to engage with blocks and use that in the 3D coding. I've got a lot of emails like individually where people have reached out and said, I introduced this to my class and my kids love it. So there's a lot of evidence out there that this is going to be a great thing that you will want to use. So we appreciate everyone being here. Like I mentioned a little bit before we hit record, if you're watching the recording, apologies for any mix up with the Zoom link or the emails that went out, but we're happy that a lot of you are here. To start with us. Luz, we're happy to have you. Chris, appreciate it. Juan, Elizabeth, I'm happy to have you here. Sandra, I mean, I don't want to Delta, and I don't know who CSP Efren is, but appreciate having everyone here on time. And with that, I'm going to turn it over to Dr. Yu, and you can get started. I'll make you a host so that you can, or a co-host so that you can share your screen and do all of that good stuff. I'll stop my share now.
Thank you, Alan. Hello, everyone. Thank you for taking this time to discuss about CreatiCode with me. So let me share my screen. So if you haven't, please sign up for a free teacher account at creaticode.com so that you can start to do some coding with me, some 3D coding with me later today. Let me share my screen. All right, so can you see my screen? Oh, I assume yes.
Yes.
Thank you. So let's get started. So this is the outline for today. So I'll introduce the CreatiCode platform for the first 20 minutes, and then I will dive into 3D programming, which is the core topic for today. And then after that, hopefully we can walk through two projects together, one smaller one, and then another bigger one, more complex game. And hopefully both can be used in your classroom as well. And then at the end, if I have more time, we can go through some more questions. So let's get started. So first of all, very quickly, a short introduction about myself. I got a PhD from UIUC in Illinois. And then after that, I went to Morgan Stanley. I worked there 11 years, mostly building automated trading systems using AI and automation. And 5 years ago, I quit my job to found the CreatiCode, the current company, which runs the CreatiCode platform. So now let's talk about CreatiCode a little bit more. So at CreatiCode, what we are trying to do is to propose a different learning path for kids when they learn computer science in the K-12 age group and hopefully beyond. So on the left, this is the traditional way how we teach kids coding, right? We start with Scratch, and then later on we introduce the script-based language like Python or JavaScript, and then later on they learn Java or C++. And as they learn these advanced languages, they also start to get exposed to new technologies behind the languages, like 3D, AI, database, cloud computing, AR, and VR. So what we're proposing is something different. We're saying, what if Scratch is enough, right? What if the kids don't have to learn another language, or at least for most kids, right? If they already know Scratch, why don't we start to show them all these exciting technologies right away? And so that's what we are trying to do. Of course, some kids will still be learning these advanced languages, right? Especially if they are going to a professional route. But for a lot of kids, what we care more about them is them, developing the creativity and get exposed to the new technologies, not necessarily, to know all the syntax and algorithms for the coding languages. Of course, that's just our opinion, right? You don't have to agree with us to use CreatiCode. For you, you can just think of CreatiCode as like a toy box, like it has a lot of new toys that you can use in your classroom with your students. And today we're gonna focus on the 3D aspect, but let me introduce the other aspects as well. So first, why did we choose Scratch? Right, so I'm assuming everybody already know what is Scratch, right, and what it does. So there are a few reasons why we chose Scratch as our starting point. First of all, it's very simple, right? The syntax, there's no excuse, right? A student cannot tell you, hey, I don't know how to use Scratch, right? Because so long as you know how to drag, you can read English, you can pretty much use Scratch, right? So it's really simple. And it doesn't require us to install anything, right? It's completely based on browser, and it runs on any platform. And also, people often miss the point that Scratch has the largest developer community. Currently, there are already more than 100 million users. Although a lot of them are still kids, imagine like in 20, 30 years, right? These are going to be adults, right? And they all know Scratch. So if you compare that to any other language, like Java, for example, there are only like 10 million programmers for Java. So this is a huge community where everyone knows the same language of Scratch, that they can share work, they can, work together. So that's something very valuable. And lastly, there are a lot of very beginner-friendly features of Scratch that makes it really successful. Like you can share and remix, you can run individual blocks one by one, right? And you can also program in your own language. So these are the reasons we chose Scratch as our starting point. Scratch is open source. So we took Scratch and we tried to make it work for bigger kids. So you can think of CreatiCode as a professional version of Scratch, where you can, if you want to, you can use it for the entire life. And we tried to keep all these strengths of Scratch as well. So what we have done to Scratch, right? So the first thing we have done is to enhance the 2D programming capability. So if you are using Scratch today in your classroom, even if you are not doing 3D, there are a lot of features you probably miss when you work with Scratch as a 2D programming language. So that's where we try to make it more complete. For example, Scratch doesn't have tables, right? You only have lists and variables. But tables is a very important data structure. A lot of people learn Python just because they want to learn how to use data frame, right? So we added back table to the language, and we also added the ability to return a value in the procedure, so it becomes a function. And we have rewritten the wiki page. So this is very important because as you or your student try to learn 3D, this will be very handy. So let me show you quickly on how it works. So you can bring out any block into the playground. So this is our playground. You can right click on it, on any block, and you can choose help. So that will bring out a new page, a new wiki page that explains how that one block works. And also it will have screen animations to show examples, like what happens when you do something. So we believe this new wiki page is more helpful compared to the official Scratch. And the same for 3D as well. You can right click on this block and say help. It will bring out a help page just for that one block. So in the future, if you see any block you don't know how to use, this would be the first thing you do, or you tell your students to do, which is to right click and open the help page. Okay. All right. So the next thing we added is a debugging tool, which is also very important as your project becomes more complex. So the most useful debugging tool is added in the control block category, which is called print. So you can essentially, this is like a logging, right? In any other language, you can print any text or any variable, or you can join them into a bigger sentence, and then you can say printed into the console. You can even specify a color. So whenever this block runs, you see at the bottom, next to the backpack, there is a console panel. So that's where all the printed log goes. Like I just printed from sprite 1 the word hello, right? So that's how the printing works. So very often when the program runs really fast, right, you can't really tell what happened, and that's where printing will help. And there are some other debugging tools. I won't go into details, like step-by-step execution or breakpoints. I will point you to where they are explained. So, and also if you are teaching loops, for example, we provide some help for you to demonstrate loops really easily. Like for example, you can just do a repeat block, and then let's say you want to do a repeat 10 times going right and then bottom, or let's do 4 times. So if you right click on any repeat loop, you can say break repeat loop. So that will convert the repeat loop into the unrolled version. And then if you right click on the stack and then say make repeat loop, they will go back. So essentially your students will have infinite number of examples of repeat loops, which will help them learn how it works. And similarly, there is a for loop, which works as the similar way. Like you can control a variable for it to go from, say, 1 to 5 at a step size of 2, right? You can right click on it and say break for loop. That will convert it into an unrolled version of the loop with how you set and change the variables. And then you can right click again and say make for loop to bring it back. So I'm not going to spend too much time on these features. If you're interested, I'm going to share this slides with you. All right. So if you're interested, you can open this, which would have all these features explained. And by the way, if you have any question, please just type it into the chat, and I'll check it. I'll check it as I talk, and try to answer them right away. Okay, so next I'm gonna start to get into 3D, which is the main topic for today. So we have added a complete 3D engine to the platform. So I want to emphasize why, right? So what's the importance of 3D? Because most of us, like as teachers, we never learned 3D when we were students, right? And we haven't been teaching 3D either, right? It seems fine so far, right? So why we are talking about 3D here? So the first reason is our students, they are already playing with 3D, or you can say 3D is like second nature for them. If you do a simple survey, like what your students play with outside classrooms, you'll probably find some play Minecraft, some play Roblox, and then there's also all these games on PlayStation or Xbox. So I would say they would cover 90% of your students. And besides games, there are also animated movies, there are AR filters, there are VR concerts. So essentially 3D is already all around us. So what we are trying to do is to bring that into the classroom, because there's a disconnection that the students feel like CS outside classroom is really cool, right? They get all this cool stuff. And then in the classroom, we're still doing very rudimental 2D programming. So if you use the CreatiCode platform, you get the chance to bring that back. You can show them, right? Like Minecraft, you can create your own Minecraft by coding, right? So that will make it much more fun for a lot of kids if they already know Minecraft. So that's the first reason why we think 3D is important to an additional component to the coding class. And then the second reason is 3D opens up a lot of new doors for creativity. Essentially, each 3D project is like a virtual universe, which can hold unlimited number of objects. So now you can build 3D games, you can create 3D art, you can design 3D things, and then you can create 3D stories. So these are new project types that opens up for new, possible creativities. And that's another reason why, it's a good addition to 2D programming. And the next benefit of 3D is that you can even just use it to introduce coding to replace your 2D curriculum, because even if you do the same amount of work and you write the same code, the results just looks much better. So for example, this is a very simple example. There are 6 blocks in this program, right? When the green flag is clicked, we initialize a 3D scene, which is a grassland, and then we add a car model from Tesla. So these 2 green blocks, they are 3D blocks, right? But after that, you can use the same 2D blocks that you already know to write to control the car. For example, here, I'm just saying forever, let's move the car 20 steps and then turn it 5 degrees. And now you get a car that's running around forever, right? So you can imagine the same code would work with a 2D car, right? But it looks much better if you have a 3D car running around. And so that's why we believe a lot of times you only need to make a little change to your code, to example programs to convert from 2D to 3D, and then the result would already be much more interesting to the students. Next point. So once they know the basics of 3D, they can actually use it for a lot of other subjects. Like I'm showing here, right? In robotics, right, or AI, they can learn how to program a self-driving car. This is for physics, and this is geometry, chemistry, solar system, geometry. Basically everything they learn in all the science subjects, they deal with 3D objects, right? Nothing around us is 2D, right? So essentially, if they know 3D programming, they can use it as a helping tool in all these other subject areas to make it more interesting. For example, right, in high school, they all learn 3D geometry. Imagine if they are able to recreate the problem using a Scratch program, right? It will make it not only easier to understand, but also probably the teacher will be very happy, right? Because it will make it much less abstract to look at the same problem. So that is another benefit of learning 3D. And then lastly, I don't know if you heard of the word Metaverse. Essentially, it's just a combination of AR, VR, and a lot of new technologies like digital twin, like smart cities, space exploration. So essentially, the Metaverse is still not final, right? Like people still don't know what exactly it is, but I can tell you this, it's gotta be 3D. Right? So if it is not 3D, it's not going to be Metaverse. So the 3D internet. So essentially, I think of Metaverse as 3D internet. So if you look at the current internet, which is 2D, right? It evolved from the text-based internet into the current 2D version, which has images, videos, animations. So it took about 30 years, right? And pretty much you can say by today, the 2D internet has hit a bottleneck, right? So every business that is supposed to have a website already has a website, right? So what's next? And many people believe the next version is to add another dimension to have a 3D internet where you can immerse into it, you can have a better experience. And also you get much more information when you add a new dimension. So this is going to be the engine for the next maybe 30, 40 years for the internet to development. So if your kids know some basics of 3D, it will help them a lot, even if they're not a programmer, right? So these are the few reasons why we believe 3D is very important and also we are ready to introduce them. I know some teachers try to introduce 3D using more professional tools like Unity, right? And it's pretty hard, I can tell you. The reason is when you're teaching Unity, for example, you're teaching three things at the same time. You're teaching the 3D concepts, and you're also teaching a new language, which is C# that is used by Unity. And then you're also teaching a completely new user interface. Like you have a lot of menus and you don't know where to find things, basically. So essentially what we are doing at CreatiCode is to simplify 2 out of the 3 problems, right? You don't have to learn a new language, it's just a scratch. And the interface is still the same. So all that you need to do is to learn the 3D concepts using the same type of blocks. And so that will make it much easier for your kids to get started. Of course, if they are interested, they can still, after they learn the basic concepts, right, they can still apply it when they learn more advanced tools like Unity or Unreal Engines. Okay, so that's the overview of the 3D component of CreatiCode. And then for the last part, I want to briefly introduce the other blocks, which are AI and AR blocks. So these are not directly related to 3D. But, of course, if you want to do anything related to AR, augmented reality, you have to know 3D programming before, right? So that's where it is related. And then for the AI services, we provide a lot of AI capabilities as blocks as well. So most of them are very simple. You just need to add 1 or 2 blocks, and then you can already have something that runs on AI. For example, right on the top right, you see this is a simple fitness app where we show a small avatar which tells the player what's the next body gesture to make. And then if the player makes that gesture, the AI will detect the different body parts and see if that matches with the target. If it does, then the avatar will switch to a new pose. And then, so that's one simple example of how you can use AI to build really interesting applications, because the interaction is no longer based on keyboard and mouse. Like in this example, you're using your body as the input. And the other new feature we added recently that I want to emphasize are from OpenAI. If you follow the development of AI technologies, you probably know, like for the last 2 years, the most exciting new development is what we call generative AI. Essentially, they help us generate new things. So in here, we provide 2 capabilities. One is GPT-3, which is for text generation. So you just need to run this 1 block, and you give it a request. For example, write a poem about the sun with a word limit of 200 letters. Then the AI will generate a poem on the fly randomly. Like every time you request, it will give you something different. And this is just one example. You can actually use it to do a lot of things, like write a joke, or write a song, write a tweet, write an email, and use it to make recommendations or answer questions. So there are unlimited things you can do using this kind of new AI capability. And the other type of AI that is also very interesting is image generation AI. For example, you can use our AI capability to generate costume images. Like in this example, if your input is a bowl of soup that is also a portal to another dimension, so essentially you get a very interesting picture generated by AI. And this is the block that you use to send your request. So essentially, so why is this interesting, right? Essentially, every job is becoming a programmer job. So in this case, if you want to be an artist, right, you don't have to be a master of using paint and color. All that you have to do is to be creative, right? You have a creative idea, and then you need to know what to say to the AI to describe your idea. So if you're describing it properly, the AI will do the rest. It will generate the image for you. Like here are all the some examples of what's generated by the AI. And I feel this is a very good lesson for all of our students so that they understand what AI can do and what's the future relationship between AI and human to work together. Okay, so that's the AI bit. Oh, by the way, this part is part of a premium service. So you don't have it if you just sign up for the free service, because we have to use third-party APIs to implement these services. So we pay them, so we charge for a little bit premium. But you can sign up for a free pilot if you want to try it out. Okay, so that's it for the AI and AR part. Now let me move on to the second part, which is about 3D programming. I see a question in the chat. Yes, all the 3D capabilities are free, so you don't have to pay for anything to get access to them. So the only thing that's premium is the AI and the AR blocks, because we need to use a third-party API for them. So now I'm gonna get into the 3D programming concepts. I know 3D is pretty much new to everyone, so I'm gonna give you some overview of what are 3D, right? What does it mean when we say 3D programming? And then we go into the two projects. So hopefully you will get a good sense how you actually do it. So first, I want to differentiate between two terms, right? There is 3D modeling, and then there is 3D programming. So the difference is when you say 3D modeling, you're doing something manually. You're not programming. You're manually creating a 3D object. And usually people use tools like Tinkercad or Blender to do 3D modeling. And in this picture you see here, that is someone creating a 3D model in Tinkercad. So essentially it's like drawing. You can think of 3D modeling as 2D drawing or painting, right? You are painting an image or picture, right? So mostly you just need to use a pen, right? So that's the equivalent of 3D modeling. And then on the other hand, 3D programming, that means you're writing code, and the code will manipulate the 3D objects. For example, make them fly or create user interactions with the 3D objects. So that is what we call 3D programming. And then the tools for that is like CreatiCode is a 3D programming engine. And also Unity that I mentioned earlier is a more professional 3D programming tool. And in Unity, you use C# to write the to write the code. And then in CreatiCode, we just use scratch blocks. Okay, so now let's talk about what construct a 3D object. So there's a link that I'm gonna send. Actually, I can put it into our chat as well. So this tool, this is a very simple demonstration of the basic elements. So for example, when you create a box in the 3D world, so what's actually happens is you start with what we call a wireframe. Essentially, there are 8 vertices, and then there are lines, edges between the vertices. So this is what gets stored in the computer system when you create a box. And then on top of these, we add faces, right? You cover up the triangles between all the different vertices, and now you get an object like a box. So that's essentially, if I repeat, you create a wireframe first, which has vertices and edges, and then you see they form a lot of triangles, right? And then if we fill in those triangles with faces, we get a mesh. And that's what we see, a real object. So essentially, they are all skins, right? There's nothing inside. If I use my mouse middle key to zoom in, you see there's nothing in there, right? It's not a solid. But if I zoom out, I see the box. And for spheres, it's the same thing, except because of the curves on the surface, you need much more data points. Like you can see here, right? This is the wireframe of a sphere. You see much more vertices and many more edges between the vertices to create a sphere like this. And then, of course, you cover up the triangles to make a mesh, which is a sphere, right? You probably noticed that you still see the edges, right? They're not smooth because in this example, I deliberately make sure all the faces they are not banded. So I'm going to show you the next step, how to make this look better. But in this example, I want to make sure it's clear to you what every object is, how they are made of, right? Essentially vertices, edges, and then faces. So next, once you have these meshes, the next step is to use the shader. The shader essentially is a special software in your display card. So it helps you to make a lot of changes to the object automatically. So let me put that into our chat as well. So when you use the shader, let me go to full screen. So this is the same sphere as from the last step, right? As you can see, there are a lot of you can see the edges, you can see the small faces, right? So the first thing the shader can do is smoothing. Like if I say smoothing, now it's like magic, right? All the lines and faces disappear. So we haven't done anything, right? The data structure underlying is still the same. It's still the same vertices, edges, and faces. But the shader makes sure they look smooth to the human eye by changing how they look, right? So this is one of the functions of the shader. And then the next thing the shader can do is to apply different colors, right? So now you can just pick adding random colors to the same sphere. And lastly, the shader can help us add textures. So in this example, I'm overlaying an image on top of the sphere. So this will make the sphere look much more realistic and much nicer. And if you probably noticed that it's not only just images, it also includes shades and shadows based on where is the light. So this is all done by the shader, right? So we don't have to do anything. We just need to say, hey, try to apply this texture to this sphere, and this is what you will get. And essentially the same is still the same underlying data that we are using, except the shader does a lot of cool things for us. All right, so that's the shader. So the next, so now you know how the objects are created. So here is an example of the key objects that are that you can use in the CreatiCode platform. So let me get started here. So the first type of object you can use is shapes. So like cubes, right? So let's say if I want to make a table, you can do it the Minecraft way, right? Essentially, you just use different cubes of different colors, and you can make any object you like the table, for example. And cube or boxes, they're just one example, right? You can use many other type of shapes like spheres or cylinders, and they all work similar ways. And then the second type of so the second type of way to make a table is to use shapes but customize their shape. For example, so because the cube I'm creating they're all using the boxes of the same size, right? But when you add shapes, you can actually use different type of shapes. For example, these are 5 cylinders, right? But you can control the diameter at the top, at the bottom, their color, their position. So this is a better way to create a table, right? Although it's very simple, still very simple, right? We just used 5 cylinders to create this table. And then the third type of object you can add is what we call models. So by model, essentially, remember what we talked about in 3D modeling, right? So models are what someone else has already created as a 3D model, probably using like a Tinkercad or using Blender. So someone else already did the hard work. You can see there are much more details compared to what we can make, right, using boxes or shapes. So this looks much more realistic as a table, right? And you don't have to do anything. You just need to load it into your 3D space. And now you get a table and a chair. You can start to, build a story around it. So that's what we call models. And there are thousands of models provided by the CreatiCode platform that you can use. For example, if you see inside, I can show you the library for that. So the way to add the table is, or any model is to say add model, and then you can click on the input box. It will show you all the models available in the platform provided by the system. And for example, you can pick a 3D glass, or you can go to the game category, and then you can pick, all kinds of interesting things to be added to your scene. So that's the third way of creating third type of objects you can add, which is models. And then lastly, you can add avatars, which are humanoid objects. So they are special because you can add animation to it. So here I have added a skeleton, a robot, and an astronaut, right? And you can have them do different things as the main character of your project. Okay, so these are the 4 types of objects that you can add into your system, into your project. And one thing that is special about object is each of them has a unique ID or unique name. So Scratch is an object-based language, right? So we continued that, but we did something on top of it. So I will explain this more after we are done with the first project. This is actually a very important concept. But for now, you just need to know every object in the CreatiCode system has a unique ID or name to it. Okay, so once you have all these objects, you can start to add actions to them. So let me open up this example and let me put it into the chat. So let's say if you look inside, all right, so I have one robot avatar, right? Remember, this is called an avatar. So the first thing I can do is to make it move, right? If I say movement, actually, I'm just making it step forward and turn as an example, right? And I can also add animation to it. For example, here I'm making it run. So this is a running animation, which is repeating forever. So the third button is combined. So I can say, let's do a movement and also do an animation at the same time. And that's what you get, right? So you see, so it looks like the avatar is running, right? Because he's moving and doing animation at the same time. Although you know that they are just separate things, but we give the illusion that they're actually running. So that is the basics of 3D actions. And then lastly, you can add user interactions. So that now the user can play with or interact with the objects. So let me open up this example. So let me see inside as well. So this is a slightly more complex project, but the idea is very simple. You can, for example, here I'm doing a mouse over, right? So essentially it looks like I'm highlighting any box on the grid. So, and when I click on it, I can add a box. And now I can highlight different faces of the box and add more boxes, right? So, and I can change the color as well. So now I'm adding green boxes. So that's the basic types of interaction you can have in the 3D world. You can pick on things, you can highlight things, you can click on things. And that helps you build a interesting user interaction. Okay, so those are the basics of the 3D concepts. And one more thing is the physics, right? So that's the last piece. So physics essentially is what we call a physics engine. So what it does is it tries to control the objects based on physics laws. For example, you all know gravity, right? For example, the game on the left, right? So you try to rotate and turn this blue board to make the ball fall onto this green ball holder, right? So it's a very simple game, but it uses the physics engine. So the engine will handle the ball rebounding and the ball falling based on gravity, right? So that's all handled by the physics engine. So essentially, if you know how to use the physics engine, you can build very interesting games by setting up the scene and then let the physics engine do the rest. And then in the middle, this is a car that is also with physics enabled, right? You can make it run, you can make it fly out from a ramp, you can make it smash into boxes. And then on the right, that's a pinball game where you can, push the ball to hit different target to get different scores, right? So these are all things you can do with the help of a physics engine. And of course, you can use this engine to teach basics of physics law as well. Okay, so that wraps up the second part of today's presentation, which are the high-level 3D concepts that you can use in the CreatiCode platform. And before we get into the projects, I want to show you, if you didn't know this, there is a tutorial page which shows all the tutorials available for our code. So let me put that into our chat as well. So this page allows you to filter by the project type. For example, here you can choose 2D only or 3D only, or AI projects or AR projects. So if you choose AR, for example, right, these are all types of AR that you can do on the platform. And of course, if you just do 3D, these are all 3D projects that you can use in your class. For example, each of them would have the difficulty level, how long it takes, and then the suitable grade. So in general, we suggest kids who already know some basics of 2D programming to learn 3D. So which is mostly middle school and high school students, but there are fifth grader or first graders who are really good at Scratch. They can also start to play with simple 3D projects. Okay, so now if there's no question, I'm gonna move on to the next part. Oh, actually, I think I have one more slide. So I'm not gonna go into excuse me. So besides, sorry, let me drink some. So besides the tutorials, we also provide a more complete curriculum for 3D coding. I'm not gonna go into details, but you can look at this video. You can look at this video afterwards, which explains how it works. All right, so for now, I'm gonna move on to our first project, which is dancing aliens. Which is also on the list for our tutorials. I'm gonna give you this link as well. So if you haven't yet, please sign up for a free account on CreatiCode.com and also open up this tutorial page. So I'm gonna go through it step by step, but I'm a big believer in self-paced learning. So if you feel I'm too slow, I'm probably gonna be too slow for some of you. You can go ahead and walk through it. And of course, you can ask me questions if you need it. But for the majority of you, I will walk through this with you just like a normal coding class, right? So we're gonna walk through this tutorial together. So hopefully after this, you would be more familiar with the format of our tutorials that can use it in your classroom. And also, so the way it works is you need to open this and also open up a playground project. So you can just go to CreatiCode.com and then create a new project. It works the same way as the standard Scratch, right? You can just click the Create button to create a project. Even if you don't have a sign in, that's still okay. You can still use the playground, except you won't be able to save it because you don't have a sign in account. But the blocks would still work. Okay, so I'm gonna give you a minute. So make sure you have these two tabs ready, right? The 3D Alien Dance Party, which is the link I put in the chat, and also create a new sign in to CreatiCode.com, and then create a new project. Any question before we start? Okay, so let's get started. So first of all, I would say always give your project a good name. So like Alien Party, Alien Dance Party, so that you won't lose it in the future. So actually, so if you click on the folder button on top right, like what I'm doing now, it will lead you to the My Stuff page. And you can see I have over 1,000 projects. So the one I created is on top, but you can also search for it, which is a feature that wasn't in this official Scratch. So if you name your project properly, you would be easy, you can easily find it when you search in the My Stuff page. So now let me get back to the project. So we're gonna work on this 3D alien dance party. So at the beginning of every tutorial, you will always see a preview, like what you are gonna get by the end. So in this case, there will be 3 aliens avatars dancing and flashing red eyes as they dance. So now we're gonna start with the first step, which is initialize a new scene, a 3D scene. So in this case, so when you create a new project, you might see that there are always 2 empty sprites added for you. One is with the Cody, the dog, and then the other is empty. So I would say just delete the dog, because that's for 2D programming. You don't really need the dog, right? You can just delete it. And then we're gonna work on the empty one sprite, which is gonna be the main sprite we are using. And then the first thing we are gonna do is to use an initialize 3D scene block. So in the tutorials, you would see that whenever you need to do something, we always show you a link. If you click on it, it will open up a separate page which explains how to do that. Like in this case, explains the initialize 3D scene block. And it always, it also explains what is a 3D scene, right? It's like a 2D backdrop, except now it's 3D. And then what are the parameters and what happens when you run it, right? So that's how you or your students can get more information about any block. So now let me go back. So in this example, it tells me to initialize a 3D scene and also add the 3D access block. So let me show you how to do that. So in our editor, on the left, you see at the bottom, right? These green categories, they are for the 3D blocks. But since it's pretty new to you, you probably don't know where are the blocks, right? You can just click on the search button, and then you can just say initialize. You don't have to finish the whole sentence, right? It's just search by partial match. So here I got 3 blocks which include the word initial, and the first one is initialize 3D scene. So I can just drag it into my screen. And then since we're looking for a grassland, so you need to click on the empty input, which gives you many choices of different 3D scenes. And then the grassland is the one in the middle. So now with these 2 blocks, right? If I click the green flag, I get a 3D scene. So now essentially we reuse the same stage for displaying, except now it's a 3D world, now 2D. And when you click on full screen, it will occupy the entire browser screen. And now you are in the 3D world. So please take some time to try to use the mouse to control the camera, right? So if you're new to 3D, right, when I drag on the screen, I'm not really changing the world, right? I'm not like shaking the world. Essentially, I'm just controlling a camera, which as I drag will look at the same world from different angles. So it's kind of like when you look at a soccer game, a broadcast, right? The stadium is the same, but depending on where is your camera, you look at different parts of the world, right? So that's what you do in 3D. So you can use the left mouse button to rotate the camera, right, around the center point, right? So you see I'm rotating around the center point. And you can use the wheel on your mouse to zoom in and zoom out. See, if I zoom really close, that's the point I'm looking at on the grassland. Or I can zoom out really far away. And then the right button of the mouse is also useful. It allows you to shift the camera. See, I'm pressing down the right button, and then I'm dragging the scene. Again, the world is not moving, right? All that is moving is the camera. But when I shift the camera center and I rotate again, I'm looking at a different point. Like my camera has a new target to look at after I shift it sideways. So actually, this is very important for you and for your students to get comfortable using the mouse to control the camera. Because a lot of times you need to look at your scene from different angles to make sure they look correct. And you need to be able to move your camera to any point in the scene to do that. Okay, I think we also need to add a 3D axis. So since I already know where it is, right? So I know it's under 3D scenes and then show 3D axis. So I'm just gonna click on the green arrow, the green plus, which will automatically add the block to my stack. So it saves me from dragging it. So now if I run the project again, I get a 3D axis in the world. So this is always recommended for new students or you, if you are new, because it tells you, give you the 3 dimensions, right? X. So in the CreatiCode world, X points to the right, Y points forward, and Z points up. So if you know Tinkercad, they actually use the same convention. However, not all 3D software use the same convention. So that's why it's important when you use a different system, you need to know where is what's the direction of X, Y, Z. So and that's why it's always good to open it up when you write your code. You can always hide it, right? You can remove this block when you are done, but at the beginning, make sure you show the 3D axis so you know the directions. And also, you see now, if I rotate my camera, it becomes more clear, right, what we are doing. Like the 3D axis, they are not moving, right? So we're just moving the camera to look at the world from different directions. Okay, so these are the first steps. Let me know if you have any question here. Yeah, thank you. Yes, so the green plus is actually very useful if you know your way around. For example, I can be programming like this. So I'm just people complain Scratch is too slow to write code, right? But if you actually already know what blocks are adding, you can keep on clicking on the plugs, and you can get a program built up really quickly. Okay, let me bring them back. Okay, so hopefully we're good on this step. Let's move on to the next one, which is to add an alien avatar. So again, there's a link on what you can do to add the avatar, which is the add avatar block. And also in our tutorial, you see we show the full screen animation, because this is a difficulty 1 tutorial. We assume the users are pretty new. So we show you the exact steps you need to add that block. So I'm gonna do the same on my screen. So I'm gonna search for avatar. I just need to type AVA. I already got the block, which is add avatar, right? And then I select the avatar. So for this tutorial, it doesn't really matter what you add, okay? You can use the alien, or you can do anything else. They all work the same way. They just look differently, but they can do the same things, the same type of animations. So I'm just gonna do the alien for now. And then, so there are two. So remember, we talked about this before. In Scratch, you can run one block at a time, right? So in this case, I'm just going to run this one block, and then it works by itself, and it added the alien to the scene. Of course, you can put it into your stack, and you can use the green flag to run it again from the Scratch. That works too. Except sometimes I don't want to run many things above me, right? I just want to run one new block, and that you can do in the 3D CreatiCode playground. All right, so now we have an alien, and then this block takes one parameter, which is the height of the alien. You know, you can make it really tall, like 1,000 units. And if you run again, now you get a really tall alien. But of course, the height is all relative, right? So depends on how far away you're looking at it, right? So I would say most of the time, start with 100 is good enough. Like you get an alien that's like 1 meter high or 1 meter tall. Okay, so that is the alien. And then next, we're gonna teach the alien to dance. So essentially, by that, we mean we make the alien do some animations. So there are actually two blocks that you need to use. The first one is to add animation, and then the second step is to run the animation. All right, so I'm going to show you on my screen here, which will be slower. Again, we're going to do the search. I'm just going to type ANI, animation. I already have the blocks I need. So I'm going to use two blocks. One is add animations, and then the other is start animation. So I'm just adding those two blocks here. So the reason is that when we add an avatar, like the alien, into the world, the block doesn't do anything, right? So the alien doesn't know how to dance. So we need to teach it by install an animation routine on top of it. This is like if you're watching Matrix, right? Like if the character doesn't know how to fly a helicopter, but we can install that software, right? That's the same idea. The alien doesn't know how to dance yet, but it will know in a minute, because we are gonna add the animation to it. So in this case, we're just gonna select the B-boy hip hop, confirm. So after this block, so if I just run this one block, now you don't see any change yet, but the alien now knows how to do this dance animation. So next step, I'm going to make it start that animation. So I need to select again and select the dance animation. So you can use most of the parameters by default, right? Essentially, the key here is we're doing looping, which means it will keep on dancing forever. So now if I run again, the alien will be dancing, right? And it's going to be repeatedly dancing forever. So if I say looping no, for example, right, it will only dance once. See, after it completes one full animation, it will just stop there, right? So because I said don't loop, but I can say yes. I'm just going to run this one block by itself. See, now it's dancing with the looping enabled. It will just keep on dancing. Okay, and this is where, for example, right? So this is where using the camera is important, right? So if I zoom in really closely, I only see the feet, right? I don't see the top, the head anymore, right? So I can right click, press down the right button of the mouse, and then I can drag or shift downward. Now my camera is targeting the upper body of the alien. Now I get to see the entire alien. So there are also, you can also use another view to look at the alien, which is this one, the half screen one. See, if you really want to look at some more details of the scene, you can switch to this view. So on the left is still a program, right? And then on the right is a much bigger view of the alien. And of course, if you have a smaller monitor, you can switch to the mini view of the alien to, you leave more space for your code. And the full screen always works any time to look at the final result. So these are the few things you can, different screen layouts you can use. Okay, so now we have an alien that is dancing forever, right? That's good. Now, the next step, oh, actually, I combined both steps. So I added the animation, and then I also started the animation. So now we're on step 5. Okay, so this is where you want to change the camera's position. So the reason is that, look, I like this view, right, for example, but if I click the green flag, it always brings me back to the default position of the camera, which is far away. It's also looking at the back of the alien, right? So to change that, I just need to set the camera to a new position. It's like you're using a program to control the camera directly, right? So if I search for camera, there are a lot of things you can do with the camera. So I'm gonna look for this one, set camera distance. So this block will allow me to set the camera's position. So the distance is how far away I am from the alien. So if I do 200, for example, right, I leave the other parameters empty, right? So if I do 200, now I'm 200 away, these units away from it. That's probably too close, right? I can just need 300, right? So you see I'm running this block by itself. So I can quickly experiment with different settings. And then so I think this distance is good, but the angle is not good, right? I don't want to look from the back. So that is what you change the H angle for. So H means horizontal, right? So it goes from 0 to 360 degrees. So if I do 180, which is the opposite direction, now my camera is in the front of the alien, right? So this looks actually pretty good already. So I'm going to leave it like that. So if I put the block back into my stack, and then if I run again, so now you see by default, the camera will be looking at the same position I specified from before. Okay, I mean, of course, you can pick different angle or distance. This is just an example. Okay, and actually, yes? No question? Okay. So actually the camera, you can do a lot of things with the camera. For example, right, let me show you something interesting. Suppose you want to make the camera rotate to the back of the alien, right? You can set the horizontal angle to 0, but you can also give it a time lag. Let's say do it in 3 seconds. So this is like the glide to XY block, right? You can use a time lag, a time period, so that you get an animation result. So for example, if I run this now, the camera will rotate to that position over the next 3 seconds. So you get a nice animation. So you can almost create a movie scene with people talking and the camera moving from different angles, completely using this one block here. Okay, so I'm gonna bring it away because we're not doing that for now. Okay, so we're done with step 5, which has a good camera position. And the next step, we're gonna make 2 more aliens. All right, to do that, So we did a lot of work on the first alien, right? We added the avatar, we taught it how to do animation. So we don't want to redo, although we can do the same thing again, there is a simpler way. We can make a copy of it, right? So, all right, that's this. So I'm just gonna search for a copy. Here, the first one is what I need, the copy object block. So when I click on it, you will notice that nothing changes, right? The reason is I just made a copy of the alien object, the avatar, which is exactly the same. It's at the same position, it looks the same, it has the same animation. That's why you only see one alien, although there are two of them. So to separate them out, I just move it. I need to move it to the sideways, right? I need to change its X position. So the good news is the original movement block, like set X, still works for 3D objects, right? So let's for example, I want to move him to the right, right? I just need to, and I know the X points to the right, right? So I just need to set his X to a different number. So in this case, I'm going to set his X to 100. So when I run this, now you see the new avatar I added is actually, now you see it, right? Because it's moved to the X position of 100. And of course, I can do negative 100, and that will get moved here, right? So because if you look from the top, right? So the X points to the right, Y points up. So that's the same as the 2D scratch, right? So essentially you can, if you want to move the object anywhere on the plane, on the grass, right, you can just use the X and the Y positions the same way as 2D, right? Of course, you can do both X and Y, right? You can say, for example, you can say go to, right? You can say go to X of 100, Y of 50, for example, right? So that should be somewhere here, right? So if I run it, then that avatar is moved there. All right, so the position works the same way for X and Y. Of course, the Z points up, right? So you would find the motion block for Z here, right? You can set its Z position as well. Let's say if you wanted to fly or float in the air, like set its Z to 200, then you get the avatar floating in the air, right? So it's right over here. And is still doing the same dancing, except its X position is 100, Y position is 50, and Z position is 200. All right, so now let me bring it back to 0. So it's on the ground. And so you see, whenever I'm ready, whenever I like the blocks, I just merge them into my stack, right? Because I think they are good. So for now, to be consistent with our tutorial, I'm just gonna say set X to 100, right? And if I run again, you get the second avatar added to the at X of 100. Because my camera is rotated to the front view, X is actually on my left, right? Because the starting point at the starting view of the camera, X is to my right. But because I set horizontal angle of 180, the X is actually on my left when I look at it from this way. So the next step is to add a third alien on the right, on the other side. Maybe you can try to do it yourself. I'll give you a minute. Okay, so I'm gonna do it on my screen now. So essentially it's the same thing, right? You just make another copy, but put it into a different X position. So I'm going to duplicate the code, which is a nice feature of Scratch, right? You duplicate these two blocks and you put them at the bottom, and then you set it to the opposite X position of -100. So now if I run again, I get all three aliens at different X positions. All right, so any questions so far? I've been going pretty slowly. I hope I'm not boring you. But I want to make sure everybody can get this done. Okay, so very good. Actually, so far we have added an avatar, and then we have made 2 copies of it, right? Because they are exact copies, they do exactly the same thing in terms of the animation. So now if you look back at our tutorial, the next step is we want to add some dancing beats, right? So a bit of forever loop, and then add some drum beats. So just for the fun, let's do it as well. So I'll add a forever loop, and then I will add the music blocks, and then we'll do the I'll make 3 of these guys, and then to bass. I believe I have a bit 2 bass for 2, and then 1 snare for 2 beats. Okay, 2 bass, 1 snare for 2 beats. So this will make sure they match with the movement, the animation beats of the avatar. So now if I play with, I'm sharing my audio, but now the alien is dancing toward the beats. Okay, so the last step is to change the eye colors. Yes, so if you want them to do different moves, you need to you can't. So the question is, can you make them do different moves? Not here, because I said copy the object and then share data. That means they are all going to share the same animations. The reason I do this is because this is the cheapest, because you don't have to reload the data. However, if you want to have an alien that does something else, it's not that hard to do either, right? You can just you just have to add another avatar like that, and then you can make it do a different dance. For example, this one will be doing the African noodle dance. So if I need to set its X position as well. Okay, so for example, here I have 2 aliens, and they are going to do different things because they are no longer sharing the animation data. Okay, so now let's go back to my previous version. So the last thing I want to add is the eye color. So to rotate the camera, you do this. You use the set camera distance block. But if you want the animation, you just need to set a different time lag. If it is 0, that means you do it immediately, right? If you give it a time period, it will do an animation over that time period. Okay, so now let's go back to the question of the colors, right? So you can customize the color of any object using the update color block. So let's go there now. So if I search for color, there are many blocks with color on it, and then the green ones are here. There are probably too many here. Update color. All right, so I'm gonna add it right at the beginning of my loop to update the color. So actually, let me just try to run the block by itself, right? So when I run this block, see what happens is I picked the pink color, right? You can do any color you like blue, right? So, but you see there's one problem. This aliens in the whole thing changed to that color, right? Which is not what we want. So to fix that, you can specify a different area. So this allows you to change different parts of the object. For example, if I select the main area, and then again, let me pick a different color. So that will only change the main body of the alien. You see the eye is not part of the main area, right? And then if I say second area, and then let's say if I pick a green color, and I run it, it will update the eyes, right? So because there are many different objects, the definition of area is different for each object. So you have to try it out like this, right? You have to, if you want to say, hey, I want to change a particular part of this object, which area it is, right? Is main or second or third or fourth? You can just try it out, right? You should be easy to find out. So in this case, we just found out the eyes are the second part or second area, right? And that's what we are going to use in our when we try to change the eyes to red, right? So we are going to change the eyes to red in the beginning of the forever loop, and then we are going to change it again after the first two beats. Right, so that it's back to a different color, like black, right? So you'll be red, and then you'll have two beats, and then you will revert back to black, and then for another two beats. So now let me run it. Let me mute my thing so that okay, so if I run again, oh, I probably added one too many. Yeah, here. I don't need to add this guy, just need to make two copies. Okay, there we go. See, essentially, it's repeatedly updating the color of the eye to red to black to red black. And that's that completes our scary alien. So now, like I said earlier, right, if you are done with the project, you don't have to show the 3D axis anymore. Right? You can just say no here in this block. And then when you run again, you won't see the 3D axis. You will only see the three aliens. All right, very good. I hope you have also completed this. Any question on this? All right, so I'm gonna talk about something very important. So please look at my screen. So so the question here is, we have three aliens, right? Remember, I showed you how to move them, right, using the set XY block, right? So now, suppose I want to make my alien move up again, jump up again, or fly in the air again, right? Let's say I do set Z to 50. So when I run this block, there are three aliens, right? So which one am I controlling, right? So that is the question I haven't answered yet, right? So we can try it. When I say set Z50, oh, this guy moved up, right? So why this guy, right? What if I want to make this guy move up? What should I do, right? So that's the key question I want to explain. So the answer is we need to give the objects names. In this case, there are three aliens, right? We can give them different names so that we can select, we can tell the 3D engine which object we are controlling. So this is different from the standard Scratch, right? Because in the standard Scratch, everything goes by sprite, right? Each sprite also corresponds to one picture or one object on the stage, right? So if you have 3 aliens, you have to have 3 sprites, right? So that if you say set X or set Y, depending on which sprite you are in, that block will control that particular sprite, right? So essentially everything goes by sprite. However, in 3D, there are many more objects that you can control in the sprite, right? For example, I have projects that have thousands of objects, right? So you cannot add thousands of sprites, right? Just one sprite for each 3D object. So that's why we added the additional layer of names. So what I mean is when you add an object into the world, right? It could be alien, the avatars, or can be objects, right? So you just need to specify a name to it. For example, I can say add avatar A in here, right? So if I run this project again, see after I add the object A, there is an object list on the bottom right below the stage. You probably never noticed this before, right? So this shows the list of objects in the 3D world that is created by the current sprite. So now let's say I add when I make the copy, I will call that B. All right. So let's say if I run again. So now I have 2 objects, and you see the object now the active object is the object B, because that's the one that's added the latest. So if you look at the dropdown, I have the ground object A and object B, right? So there are 2 objects, A and B, added into the world. And then the same here, if I give this third copy a name of C, and then I run it. So I have 3 objects, and then see I have A, B, C here, right? So this is good. Right, so now I have the name of all 3 objects. So when I say set Z to 50, right, the 3D engine will look at this value here, right? You will see, oh, actually object C is the active object. It's what we call the sprite object, right? So that's why when I say set Z to 50, I didn't need to specify which object. But the 3D engine knows it's the object C because that is the active one. That's the one that's added the last. Now, the question is, what if I want to change the one in the middle, right? So you can do that by selecting that object first. So under 3D action, the first block is called select sprite object by name. So this will allow you to set a different object to be the active one. So in this case, I know the middle one is the first one added, right? So its name is A. So I'll just need to say select sprite object by name A. See, when I run it, nothing changes in the system except the object here becomes A, right? So A is the active object. So now if I say set Z to 50, now the A object gets moved up because A is the active object. Okay, so I hope that is clear now. So essentially, whenever you have more than one object in your world, right, and you need to tell the engine which one you want to move or change, you have to make sure you select that object first, so that all the other commands you run after this block will be applied to that particular object. So again, if you want to move this guy here, his name is B, right? I just need to select B and then set. So this now becomes B, right? And then this block will be applied to object B. So now they are all floating in the air. All right, so actually, so this is important because 90% of the time, if you get something weird, that is because you are running a block against the wrong object. So whenever you have more than one object created in the sprite, you need to start to think, oh, which one am I controlling, right? Which one is the active object? And that is what we call sprite object. That is what you can change by using this block. Okay, so I think we're probably, can you apply a 50 to all? Yeah, you have to use a loop because we don't know exactly what you want to do with all of them. So yeah, you have to select them one by one and then do this for each of them. Okay, so if there is no question, let's do a 5 minutes break. So we will resume at your 7:20.
All right. Oh,
Yeah, and I'll stay here to answer questions as well. How do you loop from A to B to C, right? So now that is more like a Scratch question, not a 3D question, right? So what I do usually is this. I name my object 1, 2, 3. If I know I'm going to loop through them, I will make it easier for myself. I will make them named 1, 2, 3. So now my objects are 1, 2, 3, right? So if they're 1, 2, 3, you know what to do with them, right? You can just do a for loop you can just use a for loop, right? To go from 1 to 3, right? And then now you can select that variable, my variable, which will be 1 to 2 to 3, right? And then you can run whatever you want to do with it, like say 150, right? So if I do that, all of them get moved up to 150.
Thank you. And I see JR.
Sorry, what's that?
oh no, that was just music starting.
Oh, all right.
Do you hear me talking to you across the water, across the deep ocean, under the open sky? Oh my, baby, I'm trying. Boy, I hear in my dreams, I feel you whisper across the sea. Keep you with me in my heart. You make it easier when life gets hard. Lucky I'm in love with my best friend. Lucky to have been where I have been.
Ah, bless you. Thank you. Thank you.
Hey, I got a quick question, if that's okay.
Sure.
On my little, I did dancing astronauts instead of aliens, and I wanted to do an event block, wait like 15 seconds, and then tell all the other scripts to stop. The music's because I wanted my music to stop. Well, the music stopped, but my astronauts still dance. So does that not control the other code?
Yes. Did you use the stop all block?
Well, instead of stop all, just said stop other scripts on the sprite. That's just what I always have to use that when I'm in Scratch. I don't know why sometimes the stop all doesn't work. So if I do stop all, it should be okay.
No, it's to say no, it wouldn't, because the animation is controlled by some other logic. Because the block is just starting the animation. So what you would need to do is you have to select the alien, and then make them stop. So so essentially, well, you don't make them stop because the alien always have to be doing something. So what you actually do is you do this. You select the alien and then you make it freeze. So essentially, you can just say, for example, you can just do idle, for example. Idle. You can say start idle and then no looping, and then you can even say from 100 to 100. So essentially, they are just gonna freeze at a particular position, but you have to do that explicitly.
Okay.
See, like what you are seeing here, they are all gonna stop there, doing nothing.
Okay. All right. Thank you.
Sure. All right, so let's continue. Excuse me. So there was a question about what if you have to name your object A, B, C, right? How do you loop them? You can put the names in the list like this, right? Or it can be A, B, C or whatever, right? And then you can use a loop to go through the items 1, 2, 3 of that list. Then you can go through your objects. So that's another common way to go through things. Okay, so now let's move on to our second project. Let me give you the link to it. It's gonna be a game. It's, instead of just an animation, this time will be something that you can actually play with. As you see here, there's a ball on top of some boxes. You can click on any box. As a player, you can cancel out or remove any box. You keep doing that until the ball starts to fall. And if it falls into the green basket, then you win. All right. So I like this game because it's fairly simple, because it's using the physics engine, right? So the engine does a lot of work for you. And also it allows for a lot for your students to create new things, right? So once they know how it works, they can design different levels, like how to make the game more interesting. So there are some ideas at the end of each tutorial that we usually give, so for the kids to try to do something more, given that they have just completed this tutorial. Because, just doing the tutorial sometimes is not enough, because they're just copying the instructions, right, sometimes. So we want to encourage them to do something similar, right? Try to change it a little bit and to be more creative in creating their own level. And so this example is a very good example project that allow you to do that in your class. So if you are ready, I already pasted this link to the page. So, and we're gonna get started on this. So again, please start by creating a new project, a new empty project, and give it a name like physics or puzzle. You know, anything that helps you find it later. So let's get started. It's my 7:25. I mean, hopefully we get this done within the next 35-40 minutes to our original end time. So the first step is creating 4 empty sprites. So this is a very good practice. So in that, although the sprites no longer mean the same thing for 3D, right? So in 2D, each sprite is one image on the stage, right? It's very clear. But for 3D, I know the concept of sprite is changed, but it's still a very good idea to organize your code around sprites, right? So in this case, in this project, we are going to have 4 sprites. The first one is the main sprite, and then the other 3 are going to be boxes, basket, and ball. So there are the other 3 key components of our project. So that makes it much easier for you to organize your code. And also, if you want to make any change to the boxes, right, you just go to the boxes sprite, right? So now let's do that. So delete the doc sprite. And then for the empty one, let's change it to main. And then please add 3 more by duplicating the main 3 times. And then you can name them as one as ball, and then one as boxes, and then one as basket. So these are going to be the 3 key components of our project. And then we go back to the main sprite. Okay, again, we're using the sprites as a way to organize the code. And then there are the 3 key components of the project, right? So the boxes, the ball, and then the basket, right? And that's why we have these 4. And the main sprite will be mostly used for controlling the other sprites. Okay, next step, we're gonna set up an empty scene. So you should become pretty standardized to add these things at the beginning, right? You have a 3D scene, which is empty. You have a 3D axis, always good to show that. And then also show move the camera back a little bit to a distance of 1200, so that because this is a big scene, we want to see everything all the time. And you do that in the main sprite, because that's like the initialization phase. All right, so I'm going to do that here as well. And since I already know my way around, I'll just click on 3D scene, initialize 3D scene, show 3D axis, and then later below, I will set the camera's distance. So to 1200. See, so once you know the blocks where they are, it's fairly fast to add them and create a quick program. So after that, you should get something like this. I'll give you a minute to catch up. And our tutorial shows these 3 steps and what you should get as well. So usually your students shouldn't have any trouble reproducing the results if they follow the instructions correctly. But sometimes I do see, I do have students saying it doesn't work, and almost 100% of the time it's because they are using the wrong block. So that is something that you need to help them to appreciate. Like there are sometimes the blocks look similar. For example, right? If I just do camera, see there are quite a few of them, right? Like here are 2 blocks, both are set camera distance, right? And then there is also one which is add orbit camera distance. So they all look similar, right? But they have different functions. So if they happen to use the wrong block, they wouldn't get the same result. So that's the first thing I would check. If your student is saying, hey, I did the same thing, exactly the same thing, but I get a different result, then most likely they're not doing exactly the same thing. They're using a different block. Okay, so now let's move on. The next step is to enable the physics engine. So that is always done at the beginning. Essentially, you're saying in this scene, I'm going to use the help of a physics simulation engine, and then you need to specify the gravity. Negative means it's going to the bottom direction. So I know it's not exactly science, like we're just doing 1,000 gravity. And that is in the 3D physics category, the first block. And then we're just gonna do -1,000. So again, so when you run it, you wouldn't notice any difference. But from after this point, you can start to use physics for the other objects in your scene. Okay, so let's move on. Again, so this is more about organizing your code, right? So we're actually gonna add a message, which is add boxes. So we send it from the main sprite, and then in the boxes sprite, we receive it. So this is the recommended way of organizing your code. So let me do it here. You start by broadcasting the message, add boxes. Actually, I'm using broadcast and wait so that we wait until the boxes are added before we move on to the next step. So let me put it back. We're going to do broadcast and wait. And then we're just going to add the boxes. And then we're going to go to the boxes sprite. And then we don't need the green flag anymore, right? We're just going to receive the message, which is add boxes. Okay, so again, in the main sprite, we broadcast the message, and then in the boxes sprite, we receive that. And now at this point, another common mistake is the students adding the blocks to the wrong sprite, right? So that's why it's always important to make sure you know which sprite you are working on. In this case, we're working on the boxes, right? And we add the box when we receive the add boxes message, and that's done in the boxes sprite. So in this case, we're just adding a box, which is 100 by 100 by 100. And then we apply a grid material to make it look nicer. So let's do that in boxes. And then all the objects are under 3D object category. And the first one is add box. So we're gonna go to add it. So by default, it's 100 by 100 and 100, which is what we want. And we do need to add the grid material to make it look better. So if you search for a grid, you will find that block here. So, I mean, you can pick any color you like, right? So by default, it's going to be black surface with green grid lines on it. But let's change it to a brighter color, like a cyan color with white lines. I mean, this is where you can completely decide how you want it to look like. So I'm just gonna try a bright cyan color with white surfaces. Okay, so now it looks brighter. And then the next step, we're gonna add the physics body to the box. So that's where we're saying, hey, physics engine, why don't you start to handle this box? Just make sure it looks like a real box, right? It behaves like a real box. And that's what we do by saying, add a body, add a physics body to that box. So before this step, the box is just some object that is static, right? But after this step, we're saying, hey, physics engine, this is a box, treat it as a box with this much mass in it and this much restitution, which is how much it rebounds. And then friction is how much the friction value between two boxes or two objects. So let me do that. So it's under 3D physics, add physics body. So we're gonna do a mass of 0. So this is something, a special value in the world of physics simulation. When you say something has a mass of 0, right? So, you know, in reality, nothing has a mass of 0, right? So, but in the engine, if you say mass is 0, that means the object doesn't move, right? Gravity doesn't apply to it. So that's what we want, because we want the boxes to be floating in the air, right? They don't drop because of gravity. So I'm setting this mass to 0, is restitution to 80, and friction to 30. And now if I run it, so if you try to set mass to not 0, let's say 1, right? If I run it, you'll notice the box would drop down because the physics engine will actually start to manage the box for you. You will see it has a mass of 1, so it should be dropping, right? But if you set it to 0, that's telling the physics engine, treat this as a physics object, except it doesn't move. And so that's why it's staying where it is. All right, so next, we're gonna make many of them. And that's where we're using a big block called copy by matrix. Excuse me. So this is saying, I want to make many of them, right? So make a matrix of boxes, which is 2 rows and 2 columns and 0 layers, well, 0 additional layers. So these are all count from the center. So 2 means 2 on each direction of X. Well, it's easier probably if we show it. If you search for matrix, you will see copy by matrix from center. That is the block we are looking for. And we're gonna do 2 to 0. So if I run it again, we get 2 more on each direction on the X, on each of X, and 2 more on each of Y, right? Of course, you can try different values, like 3 for X, then that will add 3 more rows for the X. So it doesn't look right yet because of the grid lines are not aligned to the edge. So this looks strange, right? So to fix that, you need to shift the grid material by 50 units, because currently it is at the center of each box. So if you shift it by 50, you will move the grid line to the edges of the box. So now they look correct, right? So the original box we added is in the center, and then you extend it by 2 in each direction for X and Y. For Z, we didn't add any layer, so it's still this one layer. But of course, if I do 2 here as well, you would add 2 more layers above and below. So you get a 5 by 5 by 5 matrix. So for this example, we are just gonna do 0 for Z, right? We're good with just 1 layer of boxes. All right, so remember I made 2 changes, right? I added the copy by matrix for 2 in X and 2 in Y. And then I also added the grid offset so that the grid lines looks more aligned to the edge of the boxes. And I believe that's what I did here in step 8, right? For the 50, 50, 50. And you should get these as well as of now. If you don't, let me know. I can wait a little bit. The idea, so you see, we didn't do much, right? We added a box in the center, we give it a grid line look, and then we added the box body to it. So now the fixed engine will handle it. And then we copied it into a 5 by 5 layer. And we're gonna do the same thing for 2 more layers, right? So the first thing is we add 1 new box and put it on top of the current layer. So we need to move it up. So I'm gonna duplicate this add box block here, right? And so I'm gonna add it, and then see by default is overlapping with the original box, right? So I need to move up. I can use the set Z position as we did before, right? So, because you know the Z direction points up, right? So if I move it up by 100 units, right, it will be right on top of the original box. So this is actually something that's difficult for some students. So let's say you have 2 boxes, right? Both of them are 100 by 100. So let me draw it on the, where is my drawing tool? Oh, can't find it. Anyways, so just look at these 2 boxes, right? They are both 100 by 100. So their center, the distance between their center is also 100, because the distance between the center and the edge is 50, right? Half of the edge length. And then it's also 50 for the other box, right? So that's why the distance between their centers is 100. And that's why if I move the box 100 units, it's exactly above the previous box. Okay, so I'm using the set Z block. There is another, there are many other ways you can use to move the box. For example, you can say move to. And this allows you to set X, Y, Z at the same time. And you can even do an animation. Let's say you want to do set Z to 300, but in 2 seconds, right? So if I run this block, this box will move up to Z of 300 within 2 seconds, right? So that's another way to move it, but we don't need it for now. So for now, let's just stick to what we have, right? We have added a new box. The next step is to do the same things, right? You want to add it to the physics engine, and also you want to make copies of it, right? So that is what we do in the next step, which are exactly the same. Actually, we also want to apply the grid material. So exactly same 3 blocks we're going to use. So what I'm going to do is I'm going to highlight these 3 blocks, duplicate, and move them to the bottom. And now I'm going to change it to a slightly different color as well. So let's say we want to use a pink color. So let's pick a pink color. So it's always good to pick, bright color for your games. Okay, so that's the pink color. And then the other 2 blocks doesn't even need to be changed because they do the same thing. So if you run again, you get another layer of boxes. This color is probably a little bit too dense. Let me change it a little bit. Okay, that's better. Okay, so now we have 2 layers. And the third layer is exactly the same thing. Right, so you can duplicate the blocks from the second layer. You just need to change the Z position and also the color, right? So even though it looks like a lot, you can actually duplicate most of the code. So I'm duplicating from here, these 5 blocks, so which add the new blocks, and then we're gonna move it up to Z of 200 now, right? Because it has to be above the 2 layers below. And then we're gonna change it to another color, maybe light green, right? So now if I run it, I get a third layer. Now this is probably too bright. Let me change it a little bit darker. Okay, run again. All right, I mean, this color looks good. All right, so I'm gonna pause for a minute. In summary, that's all we need to do for the boxes, right? So essentially you add a box in the center, you give it some nice grid colors, and then you add a box physics body to it, and then you copy it into a 5x5 layer. And then you just do the same for all 3 layers. Oh, I hope this is fairly straightforward so far. Okay, good. Now, for the sake of time, I'm gonna move on. Okay, yes, peeking. We're not done with the boxes. We need to be able to remove any of them, right? So to do that, first, we need to turn on peeking. So peeking essentially means clicking in the 3D world. So I'm gonna do that as the first step for the boxes. So you can just search for peek. And we're gonna say turn on peeking with the left button. So it allows you to specify using the left or right button for the peeking event. So we're just gonna do the left button. So once you turn it on, you need to handle it. So by handle it, you can subscribe to a new event, which is when an object from this right is picked, right? So that is that block will be triggered whenever any block is picked. And when that happens, you want to remove that object. So now the question is, there are so many boxes, right? Which box do I remove? So the system will tell you by giving you, you can use this reporter block, which is picked object name. It will tell you which block is actually being picked, which box is picked. And then you can just use that name in the remove object block. Okay, so this is actually 3 blocks, right? So let me add them myself. The first one is an event block. Is when an object from this sprite is picked, right? So this event will be triggered whenever we pick on any block. So, and then see here is also a reporter block, which is the picked object name. So that will tell us the name of the object. I can actually turn on the monitor so that we can actually see its value. And lastly, when we know the name of that box, we want to remove it. we just need to say remove object with that name. And then we just put in here. Okay, so this is saying when the object's picked, give me the name so that I can use that name to specify I want to remove that object. So now if I run again, if I click on any box, you see the name of that object is populated in this variable, picked object name. But at the same time, because I call the remove object, that box is actually removed, right? So let me do it again. See, removed. You can click on any object to remove it. All right, so that's how you allow the user to remove things, remove any box from the scene. So we're good with that. I'm gonna hide this peak event block so that it doesn't block our view. Okay, good. All right, so of course you can still drag the camera, right? So peaking is a different event from dragging. See, if I put down my mouse and then I drag, nothing gets deleted, right? Because that doesn't trigger the peaking event. It's only triggered when I put down my mouse and then release the mouse, right? So that is counted as a peaking event, and that will trigger that object being removed. Right? If you're just dragging the camera, it doesn't remove that object. It doesn't trigger the peaking event. Okay, so now we are done with the boxes, right? So please make sure you save your project. And then let's move on to the next step. So now we are, so this is important, right? Now we're working on the ball. So we need to go back to the main sprite and then send another new message to add the ball. And then we're going to switch to the ball sprite to work from there. Okay, so let me go back to the main sprite and then duplicate this and then change to a new message, which is add ball. Okay, so, and then we're going to switch to the ball sprite, right? We don't need the green flag anymore. And we're going to handle the add ball event. All right, so so it's important for your students to know, right, from this point, they are working on the ball, right? So to add the ball, we do the same thing. We add a ball object, and then we give it a physics body so that the physics engine will handle it for us. So here we are using a volleyball model as our ball. So it's under 3D object, add model. Remember, we talked about models earlier, right? So the balls are also, there are many balls you can use. For example, if you search for ball, these are all, well, a lot of them are balls you can use. So I'm gonna just use the volleyball model. And then the height, since the ball is a sphere, right? So the height also determines its diameter. In this case, each box is 100 by 100. We want the ball to be slightly smaller than 2 boxes width, so which is 200, right? So that's why we set it to 190, which is 10 less than the size of 2 balls. So, and also there is, we need to add an offset of 95, which is half of the ball's diameter. So the reason is that when you add a ball, by default, its position is about its bottom. So when we say the ball's position is X, Y, Z is about, we're talking about the bottom point of that ball. But when you use the physics engine, we always want the position to be the center of the ball. So that's why we need to add an offset of 95. So which is exactly half of the size of the ball. I mean, you wouldn't see the ball when we add it. Well, it's here, right? It's in the center. So what we need to do is we need to move it up to the top, and we also need to give it a physics body. So let's do that step by step. First, we are going to move it to X 100, Y 100, and Z 400. Again, this is really up to you for you to design your own game, right? So when you design your own level, you probably need to decide where to put the ball. But for now, let's just follow this example to move the ball to the top. So when I run it, the ball is moved here above the boxes. Right now we can see it clearly. And then next, we are going to do the same thing as attaching a physics body. So this time, we're going to give it a mass of 1 because we need the ball to fall, right? So it needs to follow gravity. And that's why its mass cannot be 0 anymore. So let me put that in here. 3D physics, add physics body. So there are a few types of body you can choose. Since this is a ball, we're going to pick a sphere, right? And then a mass of 1. And the restitution, again, that controls how much the ball rebounds, right? So we're just going to use an 80%. So it will be fairly bouncy, but not fully bouncy, because 100% means it will rebound fully. We don't want it to be that much bouncy, so we set it to 80. And then a small fraction of 30%. So now we have a ball. So if I just run this block, you will see that after this point, the physics engine will start to take over. See, it will make the ball fall, and because it's hitting the boxes, it will rebound a little, but then it will pause there. And that is that's a good starting point for our ball. Actually, so that's all we need to do for the ball. And now we're up to the last point. Actually, this game can already be played. See, if I start to remove some of these boxes below the ball, see, the ball would fall, right? It's just that we don't have a target yet, right? We don't have, we haven't told the player where we want the ball to be yet. And that is the basket, right? That's the last piece. All right, so the last piece is almost the same, right? So you will start with broadcasting a message and then receiving that message in the basket sprite. So it's the same routine here. You go back to main, you duplicate the broadcast, and then you set it to add basket. All right, and then in the basket sprite, you remove the green flag, and then you try to handle the add basket event. All right, so to add the basket, we're going to use something called a rectangle tube. Essentially, it's just a box, but it allows you to specify to create something with no cap, because we want a basket with no cover on top, right? So that's what you do, right? You add a rectangle tube with X and Y of 200 and 100 for the height. And then the cap type is whether it has caps on the bottom and top. Here we say bottom only, right? So there's only a bottom cap and no top. And then we apply a grid material to place it, to give it some nice color. And then we move it to the front of the box matrix of boxes. And that's where we want the target to be for this game. Okay, so I'm gonna add these 3 things to my program. So first I'm gonna add the rectangle tube. which is going to be 200 by 200 by 100 height, and then cap type bottom only, right? And then I'm going to apply the grid material to make it light green. With some white lines. And then lastly, I'm going to move it to the position of -50, -350, -100. -15, -350, -100. Right. So after that, we get a basket. Of course, we haven't enabled physics yet, right? So the ball would just fall through it because the physics engine doesn't know it exists yet. So we need to give it a physics body so that the engine would know it. So you use the same block to add a physics body to it. Here, add physics body, and there is a special type called rectangle tube that's designed exactly to match with the rectangle tube object. And again, we're going to set its mass to 0 because we don't want it to be moving, right? It should be static. It should hold the ball. Okay, so if you run it now, the basket is there, right? And it can hold the ball now. So now we are actually ready to play. So feel free to try it yourself if you get it so far, right? So essentially, we want to use gravity to drag the ball here, right? So we're gonna open up the pathway for the ball, right? So I'm gonna remove all of them, and I'm gonna leave 2 of them here to make the ball go this way, right? And I'm gonna delete those 2. See, now the ball will follow through this path and fall onto my little basket. Oh, I think the ball is spinning because I didn't give any friction to it. That's why it keeps on spinning. If I go back to, oh no, it's the basket. I forgot to set the friction to the basket. Let me do 100 for the basket, so that the ball would stop because of friction. Okay, so actually that is the game. Of course, we have to check if we're done, right? So how do we know if we are done? We can check the position and speed of the ball. In this case, right, so first of all, we know, so you can use this block, get physics body property, to read the property of the ball. Right, so in here, we know our ball is in the basket. So let me try to read its information. So it's the block here, not this one, get physics body. So you can get a lot of different property of the ball. For now, let's just focus on 2 things. One, what's the Z position for the ball, right? If I click on this, oh, sorry, I'm in the wrong sprite. I need to be working on the ball, not the basket. So I'm in the ball sprite, right? So let me check the property of the ball, right? Position Z. So I get negative 19.62, right? So that's a fairly straight, accurate number. So that tells me the ball is at this position right above the basket. I can also check the speed of the ball, right? Because if the ball is falling, its speed would not be 0, right? But if it is static, its speed would be close to 0, right? Almost 0. So those are the 2 conditions I can use to verify if my ball is actually in the basket. And that's what we showed in our example as well. So we're going to use a forever loop. So, and then we're going to check for those two conditions every 1 second, right? So we wait a second and then we check those two conditions. One, whether its speed is 0 in the z direction. Two, whether its position is about negative 19.62. All right, so I'm gonna do those, add those conditions now. So I'm gonna add a forever loop in where I'm gonna wait a second each time, and then I'm gonna check for two conditions. So I'm gonna use an if with two conditions. The first one is whether the z position is 0. So if it's 0 equals the position z, right? And then the second condition, I'm gonna just duplicate and put it here. The second condition is whether its speed in the z direction is actually the speed is 0, and then the position should be negative 19.62. Of course, it may not be exact, right? You can use an absolute. You can make it subtract this value and compare the absolute value of that difference. But for now, I'll just keep it simple and do this 2 equal sign checking. So when that's true, right, when both conditions are satisfied, we can show success label. So this is easiest if you use something called a widget. So the widget is another very useful library. It's also free, right? You can add any type of widget onto your screen, like text box, labels, buttons, date pickers. So all the usual ones you use in your app. So now we just need to have a label, and then we're gonna actually give it a nice background and text style. So the label will simply say success, right? When those two conditions are satisfied, I'll just say success, right? And then I'll show the label at the bottom of my screen. So it's, let's say, set the y position to negative 120. And then we're gonna, so if you just run this block by itself, you will see a label like this, right? You can make it bigger if you like. So it'll be 260 width and height. And so when you use widgets, the only thing you need to know is you have to add it first, and then you can select it in the dropdown, right? This one is called label 1, right? You can select it in the dropdown for the other blocks when you try to customize it. Here, I can set its color to a different color, and then I can set the text to white, for example. So now if I run again, you get a nicer looking label, right? I can set the text size to bigger as well. Okay, and then I can even make it transparent a little so that you can see behind it, right? Good. So now I'm ready with my success label. I'll put it back. And that is our game. Of course, there's one more thing we need to change. Because we have added a forever to our add ball message, we have to do something here. Because if you run add ball and then wait, you will never run to the block to add the basket, right? So we need to switch their ordering. And also, we don't need the X's anymore. We can hide that. And we can change to a nicer looking backdrop as well, like the blue sky, right? So, these are just the nice touch-ons. So now let me save my project and then run it. See, now we are ready with our final game. When the ball falls into the basket, it will report success. Okay, so we're slightly over time, but I think overall we have done pretty well, I would say. That's all I wanted to go through for today. If I mean, if you have any question, feel free to ask me now. I mean, if you're good, I guess we can call it a day. It's been a long time, right? My email is right here, info@creaticode.com. So if you have further questions about the pilot program or any problem you face when you try to create a 3D project, right? You can feel free to email us at that email.
So once again, thanks everyone for joining us, and double thanks to Dr. Yu for going through this. I'm sitting back here and I'm typing a bunch and trying to figure out some stuff on my own. I've went so many different directions and I've tried to break it and fix it 10 times since I've been watching. So this is great, and I think that kids would do the same thing. So I appreciate you giving us your time, the gift of your time this week, and hopefully we got some good feedback that teachers can use. And I want to make sure that we'll definitely share this out with those who couldn't be here today. But once again, I'd like to thank you.
Sure, you're welcome. Thank you for organizing this. I mean, really nice to talk to you all. And yeah, hope you enjoy this. Hopefully this could be some new toy you use in your classroom.
Yeah, and I knew that CSTA was promoting your session at the last conference, and Connie had spoke about how she had done some work with it as well. So hopefully one of these days in person we'll get to run into you and kind of go through some things as well. So really good, and I appreciate it.
Thank you, everyone. Hi, Connie. Thank you.